Hi there, my name is Mr. Delovet. I'm a physics teacher. So today we're going to look at current electricity, specifically house wiring. So what our objective? At the end of the lesson, we need to know to describe a ring circuit and draw it, state the advantages of a ring circuit, distinguish between circuit breakers and fuses, draw a diagram of a fuse block or a 3-pin block, should be able to calculate the fuse rating of a given appliance, and should be able to explain the safety precautions of a head wire. Now, before we go on, like some prerequisite we need to know. So what do you think the type of connection is? Which type of connection is preferred in a house? Pause the video and think about it. So if you've done that and the answer is power connection. Next question. What voltage is used in housing Cameroon? 240 volt. And what is the purpose of the transformers on the streets? To step down the high voltage 11 kV to 240 volts. That's good for the house. Now, imagine electricity wiring in a typical home kitchen. The kitchen has sockets connected to appliances such as kettle, fridge, microwave, blender, iron. If all appliances were connected in a simple circuit, the wires overheat and cause fire. So instead, electricians use a ring circuit with fuses and circuit breakers to ensure safety, efficiency, and reliability. So that's why this topic is designed for you to know how your house is connected, why they put fuses, why they use 3-pin plugs, why they are putting cables, why they're using red, why they're using brown, why they're using blue cables. So all those different cables, what are the functions? Are they just putting there for putting sake? So that's why this topic is designed so you can better understand your house and you can also be safer from any electricity burns or shocks, or so you can keep yourself safe from electricity at home. Now, so what is house wiring? So electrical energy is available for household through our power stations, and the current is always alternating current. So in Cameroon, electricity is supplied is at 240 volts at 50 hertz. So household wiring is the arrangement of electrical installations in a house. So the inside component includes the incoming cables, electrical board main fuse, electricity metal, consumer unit or fuse box, appliance, lighting and ring power circuits. The incoming cable, the cable through which electricity enters the house. The incoming cables are the cables through which electricity enters the house, and it enters the house through the live cable and the neutral cable. And the electric main board fuse is a fuse that protects the electricity metal, and thus the household. So it's fitted on the live wire. So the electricity metal is that instrument that measures the energy consumed by the household or consumed by people in the house. So like for example, we have these readings here. For example, number of unit used. This, for example, reading on the 10th of November, we have this unit on the metal, and this is a reading on the 10th of December. This is the unit. So you subtract these two, you have the total kilowatt that you have used in your house. Like for example, if I used mine in my house, this is what I used. This is my metal in my house. So you see, if you look here, you have 3,802 kilowatt hour. So this is a unit here, kilowatt hour. But I lastly read this on, I think, December. It was 3,440 kilowatt hour. So if it's minus those two, you know the total amount of energy I've consumed between December 2025 to 2024 to September 2025. Yes, so this is how you read your meter. So this is the value here that you read, and then you calculate. Now you can just calculate of the cost of energy that you have consumed in your house. Now we have the consumer unit. So the consumer unit contains a main switch which breaks both the live and neutral wire to switch off or on all the circuits in the house, and it also distributes current to the several separate circuits in the house. It houses circuit breakers which protect each circuit separately. And if you see, I think most of you have seen this type of circuits, this type of boxes in your house or near your store that has something like this. Now, and so the cable used in the house is considered to read three cables that we use in the house doing electrical installations. We have the live wire, we have live cable, the live wire, the neutral wire, and the earth wire. So the live wire is always green, it's always red and brown, and it carries the AC current to the appliance. That's the function of the live wire. It carries a current to the appliance, and it varies. So it's if you always touch it, you always get shocked, and that's why they always put the fuses but on the live wire, so that if too much current is coming, it breaks open, and so current does not flow to the appliance anymore. And the neutral wire, it's blue or black, and the function of this filter is that it completes the circuit. It just create a return part of the circuit to the main supply. So that's what its function. So when you touch it, it does not really get shocked. So it does not really get shocked using neutral wire. And so we have, so these are the different colors. As you said, this is blue for the neutral wire, brown or red for the live wire. The one can also be black, and we have green, or we have green and yellow stripes on this for the earth wire. So the earth wire is green and yellow or green color. It's used for safety purposes. So it prevents the appliance from becoming live if any fault develops. So if something happens to the system, it makes the appliance not to shock you when you touch it. So yes. So what's a fuse? A fuse is a piece of wire or a thin metal strip that melts and breaks a circuit, which when a current more than normal flows through it. And the metal strip has a low melting point, and when a fault develops in the circuit, allows more current to flow, and this current causes that metal strip to get heated very fast, so it melts off, and when it melts off, it breaks open the circuit, and current does not flow to the circuit, to the appliance anymore. Now, so this is what we call the fuse in real life. So that's the wire that's found inside, and the fuse is always fitted to the live wire to protect the circuit. So it's always fitted to the live wire, because the live wire is the one that carries the current to the circuit, to the appliance. Is the one that carries the current to the appliance. So this is what we call the 3-pin plug. So the 3-pin plug, and you're required to know how to draw this diagram in your exams, like in the GCE. So this is a 3-pin plug. The 3-pin plug is mostly like those plugs that have three heads. You have some plugs that have 3 heads. They can be on your TV cable, or your computer cable, or your radio cable. They always have 3-pin heads. So the first pin that is always on top, it's the F, is what the green and yellow. We have the blue, and we have the live. This is a live, which is brown, and it's always attached to the fuse. It's always attached to the fuse, and this attached to the fuse because when this man melts, this man breaks off. So the height is. So always learn how to draw this diagram, because they always ask it in the exams. Now, how do we calculate this fuse rating? How do we calculate to know which fuse to use for a particular appliance? Now, for you to know the fuse to use in a particular appliance, you need to know the current flowing through the appliance. That's the first thing. Now, for example, they give example, if an electric iron is rated 960 watt and the voltage is 240, what's the current flowing through it? So the current flowing through this thing is 960 watt divided by 240 volt. So these two currents, so you know the current is 4 amperes. So the 4 ampere is the current flowing through that electrical iron. Now, what will be the fuse? The fuse now will be a value that is slightly above 4. So for example, if you have different fuses like this, 3 amperes, 4 amperes, 5 amperes, 8 amperes, 13 amperes, you cannot use 13 amperes, it's too big. You cannot use 8 amperes, too big. 5 amperes you can use because it's slightly above what? 4. You cannot use 4, which is exactly like this one, because you will not be able to tell whether the current is high or not. So it tells you when the current is more than normal, and it switches off. Yes. So fuses are available. So that's how you know the rating of a fuse for you to use. So fuses are rated according to the current. So if you want to go and buy a fuse, they'll either ask you, is it 3 amperes, is it 5 amperes, is it 8 amperes, is it 30 amperes? They'll call it 30 amp, 5 amp, like that. So the one you use should be a one that is slightly above the current that is passing through that appliance that you want to use it for. Okay, so what's the difference between a circuit breaker and a fuse? So a circuit breaker also is a safety device which interrupts the circuit can cut off the current whenever current is too large to be safe. So now in this T1 is that the current switches off, and when the other one feels that it melts and breaks open. So the difference between that is that a circuit divider melts and breaks the circuit when excessive current flows. But a circuit breaker is a circuit divider automatically switches off. So take note, it switches off and off the circuit when the excessive current flows. So works once, fuse. The fuse wire when melts cannot be replaced. But for a circuit breaker, you can reset it and use it again. But this one is very fast in cutting off current, but this man takes some time before it breaks off the current. So these are the difference between a circuit breaker and a fuse. Now these electrical wires, the three electrical wires are either connected as a lighting circuit or a ring power circuit. So the lighting circuit is a low current circuit containing electric bulbs connected in parallel or protected by a 5A fuse at the consumer unit. So these bulbs are connected in parallel so that if one fails, the other one continue working. So, and we have the ring power circuit, or the main circuit, which is a domestic electrical wiring system in which the individual outlets have their own fuses. So the outlets are all connected in a ring, in parallel in a ring, and the ring is protected by a 30-amp fuse at the consumer unit. So this circuit now at both ends, each wire are connected to the main switch. So the circuits are wired in parallel across the supply wires, implying that if one socket fails, the other one keep working. So in this system, the live and neutral does not meet, so that it can help you avoid you getting shocked when using these systems. And what's the advantage of this system? So first, this is the system, this is how it looks like. And so this is how it looks like. So we have so you see these are sockets, which are the outlet, we call them outlets. These are another ones here, this one, and you have this one, the different outlets. So we have the main switch, and this you have this is live, the earth, and the neutral. So you start from here. So from here, this is live and this is neutral. So it comes, this is a fuse that protects the circuit. The fuse that protects the circuit, that protects the ring circuit. It comes, and each of these outlet have their own fuse. If you look here, where you have the live wire, you see you have the switch. So there always a fuse here. There will also be a fuse, and all of them have their own fuses so that it protects the circuit separately. Now we have this is a summary of the electrical fire system. So we have, like for example, this is a fuse, the electrical mainboard fuse. That current leaves here comes to the meter. The meter measures the current consumed by the individuals or the participants of the house. It comes to the main switch. The main switch now distributed now to the different circuits in the house, your lighting circuit, power circuit, and the appliance circuit. So all of these, the circuits and the main switch, form what we call the consumer. All this what we call the consumer box, or the distribution box, or the consumer unit. So, and you see this is what we call the ring main circuit, and this one the lighting circuit. The one connects the bulbs, the one connects the sockets, and this also any appliance that takes more current than normal. So the one is protected by 30 amp, the one is protected by the 5 amperes. So this is like how the current flows into the house and the different systems. Now, what's the advantage of ring main circuit? The first advantage is that you have two conducting parts, so to each socket. So any appliance or each of any appliance, of each of which carries half the current needed. It reduces the risk of overloading. It's less expensive. One cable supplies many outlets. So fuses and plugs and fuses are standardized. So that's the advantage of using a ring main circuit. And what the dangers of electricity? It causes electric shock, burns, fires, explosions, damage to appliances, electrocution, and power surges. And how do you deal when a high tension cable falls on the ground? First, you have to stay away from that immediately. Do not touch the cable or anything it touches. One other stay away from the area Do not attempt to remove the cable yourself. Call electricity company to emergency service to report the falling cable immediately. If a person is in contact with the cable, do not touch them directly. Call for professional help. If you have a vehicle and a cable falls on it, stay inside until professionals arrive. The car acts as a shield. If you must leave because of fire, jump clear with both feet together without touching the vehicle and ground at the same time. So it's very important, and there are a lot of safety precautions to take when you're working with electricity. You don't touch electricity cables with your hands, or where your hands are wet. You have to read electrical manuals before you start using electrical appliances. So there are a lot of safety precautions you need to take. So this video is courtesy of a video I took on YouTube for you to just see what happens with electrical high tension cables. Is very dangerous. It has 11,000 in Cameroon. It's 11,000 volts. If it touch you, you just become ashes. So it's so high. So very careful. So I just want to just play it for you to see how dangerous it is, and you should be very careful when they're working with that.
Why is it said that when a high voltage line falls to the ground, one must never run? When a high voltage power line falls to the ground, it instantly creates a series of concentric circles spreading out from the grounding point. This forms a strong electric field with a radius of about 20 meters. At this time, there will be a potential difference between the circles, known as step voltage. When both feet are on the ground, the high voltage current will create a path between the human body and the earth. The current will flow in from one foot and out from the other. This can cause severe or even fatal injuries to the human body. However, there's no need to panic, as the solution is quite simple. If you ever find yourself in such a situation, remain calm. As you approach the grounding point from a distance, the voltage is not yet lethal, but you may feel a slight numbness. Remember, you must not move forward, and you must not hastily run away. All you need to do is lift one foot and hop back away from the electric field area. If you are unable to jump with one foot, that's okay too. Keep your feet together and jump backward to a safe distance. You can also rub your feet against each other and move a few centimeters at a time. Remember, both feet should never leave the ground simultaneously, and you should not walk directly with large steps.
So it's very important. So the precautions I've said is very important for you to take. Don't overlook sockets or plugins. Use a correct fuse or circuit breaker for protection. Always wear rubber shoes when you want to work with electrical appliances to act as insulators. So note about your safety precautions is very important. And lastly, so I just want to do the exercise. So like this exercise is asking us to calculate, for example, how to calculate a fuse rating. So how do you do that? As I said before, for you to calculate a fuse rating, you have to first know that how the current flowing through it. So if you know the current flowing through it, so what do? You have to first calculate the current. So they are given the power, it's 1000 watts, and the voltage is 240 volt. So current will be equal to power and volt, which should be 1000 watt over 240 volt. So this one take care of this. We have 4 year, how many times? 8, no, 4 year 6, 4 year 25. So you have 625 on 6 ampere, which is same as same as 4.1, 4.2 amperes, something like that. Now if you have some 0.2 amperes, that is the current flowing through the appliance, electrical appliance. So what will be your fuse? Your fuse rating either be 4.5 or 5 amp, depending on which one is available. So that's what you're supposed to have. Now, so you have an assignment. You can pause the video, look at these questions here. You can describe them to get better understanding of what I've said, and if to test whether you've understood the lesson. And if not, you can go back and watch the lesson again so that you can better understand. And if you want further follow-up, you can click the link on the description to come to my group so it can better help you to get better understanding on physics and give you solve more questions so you can better understand. Thank you so much for watching and have a blessed day.